So hello everybody. Unfortunately I can't make it to the conference, so I'm going to do a video presentation which will be something different. Now I know what you'll be thinking, Brett, this is a great way of keeping me to time, so if I go over time you can just hit the stop button and that'll do. So I'll kick off. For those that don't know me, my name's Dean. I'm the IWN Program Manager for Leak Detection, Condition Assessment and also Infiltration. So the first thing I want to touch on is the concrete sewer pipe tester. So we've completed all the trials with that device and it's been quite successful. Our next step is to have a chat with South East Water and see if we can develop this technology. So you'll see on this slide, the current device works up to 300mm in diameter, concrete pipelines. So what we're exploring is whether we can come up with something that can do larger diameter pipelines. For those that haven't seen this device in action, this is the penetrating device that's just about to penetrate the roof of a concrete sewer pipe, and it's pushed up the pipeline with a CCTV tractor. So just doing its thing there. It'll measure the penetration. Once that measurement's been taken, it can determine the remaining life cycle of the pipe. Now you can do this on any frequency, so you can do it every couple of mils, you could do it every metre, whatever suits. And it's just withdrawing then, and those results are recorded. So another trial that's just been completed is the satellite active asset risk monitoring trial. So this trial was out at Bright with North East Water, and some of the things that it focuses on is terrain motion, vegetation intrusion, pipeline asset risk and asset risk zones. And what that's about is to have a look at your water and sewer network and identify areas of interest. So it might be a higher risk, so you can focus on it a little bit more. So here's an example of what a plan would come back like. So this is a sewer system. So it'll highlight some areas of interest, and then what you can do is you can do some follow-up work. So here, you'd run a sewer CCTV program and validate some of those results. So if you've got large networks, it's a really good way to refine where your issues could be and then investigate it and hopefully be proactive so that, rather than something going wrong, you can find out the issue before things sort of hit the fan. Pcap, so some of the people around the table today would have seen this Pcap video. I'll share it again, mainly because Western Water has conducted some Pcap work, so I thought it's worth sharing those results with the group.
Pcap is a non-invasive, non-destructive, reliable and safe method of performing pipe condition assessment while the system is still in operation. We're able to identify and locate small defects in long stretches of pipeline. By identifying and replacing only those sections of potential failure, millions of maintenance dollars can be saved. A pressure wave is injected into the pipeline. As the wave travels through the pipeline, it is partially reflected when it encounters change in the pipeline structure. This technique detects deterioration in wall thickness and provides remaining thickness, pipe material changes, blockages, air and gas pockets, and more. We are also able to provide the wall thickness throughout the length of the analyzed pipeline. This information can help water utilities make smart, informed, and economical decisions about infrastructure repair and maintenance, all with minimal disturbance to the system.
So back in 2014, the IWN conducted a trial with the Pcap technology, and you can see the result there. It came back with that 80% accuracy. If you're wondering how that was determined, is that we had known issues, so previous breaks, things like that within the network, and we didn't share that information with the contractor. So as they ran the Pcap technology through the pipelines, we validated it via known issues, and that's where they roughly got to the 80%. Some of the points here, it can survey kilometres per day, and on behalf of the IWN, we recommend that as a business as usual tool. We've also negotiated a special rate for IWN members. So the reason I'm going over this again is that in 2016, Western Water had a break on one of its larger mains. It affected roughly 2,000 customers, so a pretty big deal for us. And then the question we've got, is this a one-off or do we have more issues with that pipeline that could cause us problems down the track. So what we did is we got the Pcap technology in and we conducted 6 kilometres of survey to test the condition assessment of that pipeline. So you can see here, these are the areas that we covered, not just the area where we had the break. And what we found out is that we do have some issues with that pipeline. We did the same thing that we did last time. We validated it against known issues, so we've got a record of where we've had breaks in the past. And by validating it, you can see that the technology is improving. So we landed roughly around the 85% mark, which is a good result, and a good result for us at Western Water too. So the areas where we've got issues, what we're going to do is put them on the mains replacement program and fix them, rather than just wait for them to fail again. The next device I'll talk about is a sewer access point penetration robot. This technology goes off the same theory as the sewer concrete pipe tester. So what we're doing now is we're testing the integrity of sewer access points, manholes so to speak. So you can see here that Western Water's got roughly 22,000 sewer access points within its network. And what we want to do is we want to understand their condition and also prioritise their remediation work. So that could be relining. So we've got a few organisations that are interested in this: Golden Valley Water, Central Highlands Water and Western Water. We've conducted a couple of field trials and we've still got a few more to go. So how the device works is that we lower it into the access point and it can penetrate the wall on any frequency. You just lower it down and test the wall of the access point. So with that, we collect the results, and then what we can do is prioritise which manhole access point needs work in a priority system. So it puts a little bit more science around it. Our second round of validation will happen over the next couple of months, and we'll go out to Central Highlands Water and Golden Valley Water. Oh, the other thing I should share too is that I'll be presenting with La Trobe Uni as a joint presentation at Ozwater next month on this project as well, which will be quite exciting. And the other thing worth mentioning is that this device and also the concrete sewer pipe tester will be available at the IWN stand at Ozwater as well. A little bit about something that's close to my heart, the Iawn Network Operator Development Program. That's been up and running now for, I think this is the 3rd year, and we've got a spot on there to share some IWN learnings. So each year I present on IWN water and sewer innovative technologies and share that with the up and coming Network Operator Development Program and the candidates from each water corporation. So you can see some of the feedback that's come back. Love the introduction to the IWN. Some people hadn't heard of the technology. They like the innovative thinking. So some real positive feedback, and I'm sure at the end of this year I'll also get some more. So what's in progress? So I talked about what's completed. This one's interesting, and I shared this at the last conference, the Aquapede. I'm still having discussions in relation to that. So what we've done since the last conference is that we're building a pipe test bed at one of our depots, our Melton depot, that we can test some of this technology. It won't be there just to test technology, it'll also be there for training of our new employees. So we'll have a range of different materials. We'll have PVC, poly, cast, ductile iron, which will allow us to do some training in relation to tappings and main repairs, but we'll also use it for testing technology. So with this Aquapede, see the hole there? Here comes the peak, boom, seals the leak. So we'll test this technology out on that trial bed, which should be ready in the next couple of months. The initial information on this type of technology is that it could be suitable for services or small diameter pipelines. And just say you had a service leak under a road, you might use something like the Aquapede to do a temporary fix until you can go in and replace that service. The other thing that I'm working on is the smart sewer lid. So this one's quite interesting. I'm having discussions with Telstra at the moment, and the reason I'm working with Telstra is around their NB-IoT communication network. So the smart lid will use that as its form of communication, and what it will focus on is the level of the sewer. So it'll have a float gauge in there, It'll conduct sewer flow monitoring. It'll also conduct H2S monitoring, and if the lid moves, any movement in the lid, it'll trigger off an alarm. So all of those devices are in the one lid. The thing that excites me about this project is that if you wanted to do an assessment of your network, rather than having these fixed devices in the network, is having it adapted to a sewer lid. You can move it around your network, so you can do some tests in one area and then move it to another when you're done. The other one that's in the pipeline, so to speak, is the sewer pill. So I've presented on this a couple of times. It hasn't been forgotten, and I need to acknowledge Prith, who's doing all the heavy lifting in relation to pulling together a business case. So we're getting pretty close with the business case now, and the expectation is that it'll be ready next month. And what the sewer pill will focus on is GPS tracking. So it's a pill that will travel down the sewer network. If it hits a blockage of some description, it will stop, and you can notice that via your GPS tracking device. And then what we can do is deal with that blockage before there's a spill or an interruption to our customers. We're also investigating whether we can get this camera to work on the device as well. So thank you to you, Prith, for your work on the business case, and hopefully we're getting a lot closer to having this project finalised and getting it up and running. So that's pretty much an update on the IWN projects, but there's another project that I want to share with the group, and it was just something that we're working on at Western Water. So I'm not too sure if anyone's heard of this, NDVI, Normalised Difference Vegetation Index, and I'll mention how we stumbled across this. So initially what we're doing, we're using drones for leak detection on our potable network, and we're investigating a pipeline that was in a rural part of Sunbury. So you can see here, hopefully, there's a bit of a green patch. These little dots here are cows. The cows are happy over the summer. The customers don't report the leak because they're happy, because their cows are happy. But long story short, when we put this NDVI overlay over it, you can see there's a real big difference around the vegetation. And what it's showing us is healthy vegetation. So I thought, okay, that's interesting. How can that help us? So what we're thinking is that healthy vegetation, or understanding where the healthy vegetation is, over the sewer network would be interesting. So again, at Western Water, 95% of our sewer blockages are caused by tree roots. So we wanted to apply this theory to the sewer network and see what we could find out. So we used a drone company that showed us that example, and we've also used a satellite company, and what we're going to do is compare the results. So we've got two sites in Sunbury. You can see here, this is our sewer network, and it's highly vegetated through this area, and that's why we're interested. And similar, the other part in Sunbury, it's running through a reserve. So what we're trying to work out is that is one tree healthier than the other, and could that be because the roots have tapped into the sewer main, and that's what's making the vegetation a lot healthier than other trees. So we've got some results from the drones, and we can see here that there's some spots with healthier vegetation. So it looks like that is proving successful. What we need to do next is to conduct some sewer CCTV to validate those results. So again, here the drone's showing some promising areas worth investigating. Also, I mentioned about using satellite technology. So satellite also can conduct NDVI. So what we're trying to work out is that, is the technology more successful with a drone or with a satellite? So over the same site, so they're comparing the same things. Some early learnings, and you're probably not surprised about this, is that when you get the lowest resolution, it's a bit blurry and not as accurate. Whereas if you want to pay a little bit more and get the higher resolution, it can be quite specific about where the healthier vegetation lies. We've also come across this worldview, which might be the next best thing after NDVI, but we want to explore all our options, and it can do something similar. So what it's doing here, it's showing us in a different format where the healthier vegetation lies. Similar to the drone is that this type of resolution is a lot blurry, so you get what you pay for. So this one's got a 3 metre resolution, and what we can see here is it's a bit hard to read and not that specific. So where to from here is that we'll compare those results. What we're hoping is that we can find a sewer blockage before it actually occurs, And like I mentioned earlier, is that with 95% of our blockages caused by tree roots, hopefully by looking at the vegetation, we can predict where some of our next blockages will be occurring. So what I'll do is I'll keep working on this, and when I get some results, I'll share them with the group. Now this is my favourite slide today because I can ask for any questions and I know I won't get any. So thanks for your time. I hope you have a great conference. I'm disappointed I'm not there this time, but I'll definitely be there for the next one. So thanks everyone.